In the problems that we've seen so far, the state is just a value. For example, the city where we are at the beginning of day T, the inventory that we have, the cash that we have on hand, the wheat that we have on hand, and so on. So they're all just a value. And in the previous video, we've seen that we may have more than one states, but both states is just a value, the amount of cash, the amount of wheat. Now, in this example, we are going to see that the state can also be a set of values. So not just one single value, but a set of values. So let's start. This example is called the traveling salesperson problem because the analogy is the same with the job of a salesperson who goes from door to door, from one customer to the next customer to the next customer again to offer something like a product or a service. Similarly, here somebody called Walter Glenn is currently in New York and he must visit Miami, Dallas, and Chicago and then return to the headquarters in New York City. Walter wants to minimize the total distance he must travel, so the question is in what order should he visit the cities? So the distance between the cities are given in this table, and then one thing here is that he must visit each city exactly once. So he starts from New York and then visit, let's say, Miami and then Dallas. He cannot go back to Miami because each city must be visited exactly once. Of course, with the exception of New York, because he starts in New York and finally he must return to New York. You may want to pause this video for a while to read this problem carefully before you continue. Let's start by dividing his journey into 4 stages. So the first stage is going from New York to a city. We don't know yet which city, so let's just call it city X. And then the second stage is from that city X to city Y. And then the third stage is from city Y to city Z. And finally, from city Z, return to New York is the very last stage. To make a reasonable decision, we need to know where we are at the beginning of the stage, right? For example, we can't decide to go to Chicago if at the beginning of the stage we're already there, right? So we need to know where we are at the beginning of the stage of the journey. And then second, in this example, we can't visit the same city twice. So we need to know all the cities or the history of cities that we have visited so far. So we again have 2 states here. One is where we are at the beginning of the stage, and then the second is the set of all cities that we have visited so far. As usual, let's start from the very last stage. In the last stage, we are at city Z. We don't know yet. City Z is, it can be city 2, Miami, it can be city 3, Dallas, it can be city 4, Chicago. But wherever we are at this stage, the decision is very clear, going back to New York. And that's the only possible decision, right? Because we have finished our journey, we have visited city X, Y, and Z, so we have finished 3 of them, and then the only possible decision is return to New York. So the set of cities that we have visited so far must be this set of cities: city 2, city 3, and city 4. Because this is a set, the order is not important. So this doesn't mean that we've visit city 2 and then city 3 and then city 4. No, it does not mean that. It just means that we have visited these 3 cities in whatever order that we don't know yet at this moment. We just say that this is the history of the cities that we have visited. Okay? So let us put some numbers. So we say that at stage 4, the only possibility is to return to New York. Okay, so you see here, all of this says to City 1 because City 1 is New York City, and wherever we are at the beginning of stage 4, the only possible decision is going back to City 1. Now, at stage 4, at the beginning of stage 4, we can be at City 2, Miami. We can be at City 3, Dallas. We can be at City 4. That's why you have 3 rows here. Because if we are in Miami, this happens. If we are in Dallas, if we are in Chicago at the beginning of day 4, they are all possible at this stage. Okay. So here, the first number that you see before the comma is the city where we are at the beginning of the day 4. And here you see in the curly bracket is the set of cities that we have visited so far. Because this is the stage 4, the very last stage, and then we are going to return to New York, it must be that we have visited all the cities that we need to visit. So the history says we have visited the City 2, City 3, and City 4. Again, it's not necessarily in that order, it's just the set, just the history, not in the order. Okay. So let's say we are at City 3 at the beginning of stage 4, which means we are in Dallas, and the decision is going back to New York City. So F4 3, 2, 3, 4 equals from Dallas to New York 1,559 miles. So that's why you see this number here. Okay. So let's move one step back to stage 3. If at stage 4 we have completed all the cities that we need to visit, at stage 3 we have only visited 2 out of the 3 cities that we need to visit. Okay, so here we must list all the possible 2 cities that we have visited. Maybe we have visited Miami and Dallas, 2 and 3. Maybe we have visited Miami and Chicago, 2 and 4. Maybe we have visited Dallas and Chicago. Now, let's take a look at 2 and 3. If the history says that we have visited City 2 and City 3, the last city where we are at the beginning of stage 3 can be City 2, can be City 3, right? The history just says that you have visited Miami and Dallas, but then there are 2 possibilities. Maybe you visit Miami and then Dallas, such that at the beginning of day 3 you are in Dallas. Maybe the order is you visit Dallas and then Miami, such that at the beginning of stage 3 you are in Miami. That's why you see F3 2, 2 3, and then you also see in the next row F3 3, 2 3. Because remember, the set, the history of the cities that you have visited is not in order. So 2, 3 can be you visit 2 and then 3, can be you visited 3 and then you go to 2, right? That's why for each of this history you have 2 pairs. F3 2, 2 4, F3 4, 2 4. And then finally for 3 and 4 you also have F3 3, you also have F3 4. Because this is about where you are at the beginning of the day 3, and then this is the history of the cities that you visited so far. Okay, and then let's see F3 4, 2 4. Okay, so at the beginning of day 3 you wake up at Chicago, and then you have visited Miami and Chicago. So the only possible decision is that you must go to Dallas. That's why here the decisions say go from 4 to 3. because the only city that you have not visited is Dallas. Okay, so the distance is 921 is from Chicago to Dallas. Plus, do not forget that you will wake up in Dallas. So F4, 3 with the history of the cities that you have visited, 2, 3, 4 at day 4. Okay. Another example. Let's take a look at the first row here. Here it says at the beginning of day 3, you wake up in Miami. You have visited Miami and Dallas, city 2 and city 3. So the only possible option is go to Chicago. Okay. Miami to Chicago is 1,397. And then do not forget to plus the distance of F4 where you wake up at Chicago, right? Because the decision here says go from 2 to 4. So at the next stage, you will be at city 4, okay? You may want to pause the video again and make sure you can convince yourself to calculate each of this row. You get the reason why all this number appear like this, okay? Please do that. If we go further back to stage 2, it means that we have only visited 1 out of 3 cities that we need to. So maybe we have visited city 2 only, maybe we have visited city 3 only, maybe we have visited city 4 only. If you have only visited city 2, of course you will wake up at city 2, right? Because that's the only cities that you have visited so far. So you must wake up at that city, right? Let's say city 2 means Miami, so you go from New York to Miami. Of course, at the beginning of next day, you wake up in Miami. Similarly, if you have only visited Dallas, you wake up in Dallas. You visited Chicago, and then you wake up at Chicago on the next day or at the beginning of stage 2. Okay. Now here you have more than one options, because let's say you have only visited Chicago. Now you have the option either going to Dallas next. Going to Dallas means this, going from 4 to 3, or going to Miami, 4 to 2. If you go to Dallas, it means you get the distance. You get this distance from Chicago to Dallas, which is 921, plus F3, 3, right? Because you go from city 4 to city 3. So at the next stage, you will wake up at city 3, and your history is updated to become 3 and 4. However, if you go from city 4 to city 2, Miami, you will get the distance from Chicago to Miami, 1,397, plus F3, 2, because you go from city 4 to city 2. So on the next day, you will wake up at city 2, and your history is updated into 2 and 4. Okay. Because you have visited city 4 at the beginning of stage 2, and then you decide to go to city 2. So your history becomes 2 and 4. Again, this is the set of cities that you have visited. It doesn't have to be in any order. So 2 and 4 and 4 and 2 is just the same. You can write it down any way you want. But just to be neat, maybe you want to sort it from the smallest number, like what the textbook does, okay? And then because you have 2 possible options, let's say you wake up in Chicago, you have the options to go to Miami, you have the options to go to Dallas. Now, as usual, we have curly brackets, which means that you have 2 possible options. And the one that is the minimum, you give the label of an asterisk. Do the same for F23, comma 3, and then f2 2, comma 2. Finally, we have reached the beginning of the problem where f1 1 must be the case because we start at the beginning of this day at New York City, and the history is still an empty set because we have not visited any cities that we must. Okay, we haven't visited either Miami, Dallas, or Chicago, so our history is still empty. There are three options here. We can go to Dallas, we can go to Miami, we can go to Dallas, and we can go to Chicago. So these are the three possible options. Let's say if I decide to go to Chicago, it means that I experience the distance of 809 from New York to Chicago, 809 plus f24, comma the history 4. Okay, because I go from 1 to 4, so at the next stage I will wake up at city 4, and then I update my history saying that I have visited city 4. So I go from 1 to 4, which means I experience the distance from 1 to 4 plus this is f2 4, comma 4. Okay, we have some possible decisions. Put curly brackets, and then the minimum ones put an asterisk. Here we have two optimal solutions. So if you go by this plan to visit those three cities, it's okay. The total distance will be the same if you go to this plan. So the optimal solution is, for example, I go from New York to Chicago, and then if you follow the label of the asterisk, you may find that this is the optimal solution for Walter Glenn's journey, with the total distance, as we've seen in the previous slide, is 4,407 miles. Okay, convince yourself that you may you know how to get this optimal solution after you finish all the stages up to stage 1. If you are not sure how you can do this, please go back and review the previous videos from week 1 and week 2, especially from the week 1. Okay, so here's the summary of this problem. We have the stage, let's say is the day, so day 1, 2, 3, and 4, or you can also say this is the stages of his journey. But just assume it's day. And then we have two states here, the city where we are at the beginning of that day, so we call it I, and then the set of cities that we have visited so far, we call this set as S. And the decision is the next city we are going to visit. Let's call this J. The recursion looks like this if it is day 4 at the end of the journey. So t equals 4, I, S equals ci1, which means the cost or the distance from city I, where we are at the beginning of day 4, going back to city 1. City 1 is New York. So that's why this is ci1, because we must go from city I to New York. We must return to New York at the end of this problem. However, if t is less than 4, this is the recursion. ft I, s means that we go from city I to city j. We get the distance cij plus ft1, because we go from I to j. We will wake up at city j in the next day, or in the day t plus 1. Plus we will update our set of cities that we have visited so far by adding city j. Because S is a set, the correct notation to say that we're going to add an element to a set is using this symbol of union. So we are going to add the element j into the set S. And then if we have a lot of possible cities J that we can visit. So we put a curly bracket, and then we are going to find the minimum among all possible J, but J cannot be a member of S because S the cities that we have visited so far. So you see here J is not an element of S, and then J is also not city 1 because city 1 is New York. Before day 4 you cannot go to New York, right? So that's why you see here there's a small thing here saying that J is not an element of S, which means that we can't go back to the cities that we have visited before. And also J does not equal to 1, means that we can't go to New York before day 4. Okay, so that is how we solve this traveling salesperson problem using dynamic programming. And in the next video, we are going to see another type of recursion, which interestingly quite different, because usually we have seen that the recursion problem, the recursion function, I mean, involves the addition sign. But in the next 2 videos, we are going to see that that is not always the case. So see you on the next one, and thank you.